Okay, right. Should we get started, everyone? Amazing, perfect, thank you. So I'm really delighted to welcome Orit back to UCLIC. We were just discussing, or it was here at UCLIC many, I won't say the year, but we were in Rimack's house and we were reminiscing on our times at Rimack's house. And we thought after the seminar, on the way to like a beverage and food afterwards, we might go for a walking tour through UCLIC's potted history of Bloomsbury. So you're more than welcome to join us for those of you who are interested in our former homes. Anyway, over to you, Orit.
Great, thank you. And it's really such a pleasure to be here. When I was here 2005 and 6, many years ago, I was a PhD student. That was quite a while, so I'm excited to be here and share my work and the work that I'm doing with my students. So I'm a professor at Wellesley College, and I'm chairing the computer science department there. And Wellesley is a very different setting to UCL, so I thought I'll just start with a short video, but it's a liberal arts college for women. So we have undergraduate students emphasizing kind of the liberal arts, the multidisciplinary environment and connections across disciplines, really aiming for a 4 years kind of wide education. So students are kind of getting well-rounded background, both in computer science as well as in the humanities, the social sciences, and other disciplines. So just a short marketing video, but I think it will give kind of a sense of where I'm coming from, and I need to get that to work. Right, so you can see kind of Wellesley mission is to educate women who will go and make a difference in the world. So working with social justice issues and thinking about societal implications is something that is really part of the fabric of whatever we teach or conduct research on. And in case you don't know, Wellesley is in Massachusetts, next to Boston. So, great. And going back. Sorry, this display doesn't. Okay, perfect. And here's a picture of my research lab at Wellesley. So this is a very multidisciplinary space. The work is mostly with undergraduate students, and I have students with background in computer science, media art and science, data science, but also students that coming with background in philosophy, in the social sciences, in biology, in chemistry, and education. And this multidisciplinary environment is really critical for the work that we do and the way that we conduct research. My field of expertise is human-computer interaction, but specifically, I've been thinking a lot in the last really 2 decades on tangible and embodied interaction. In the last 7 years, I've been working closely with Brie Gulmer, with Ali Mazalek, and with Caroline Hamos on putting together what we like to call the story of tangible and embodied interaction as an emerging field. So this is an emerging field that aspires to make the interaction between humans, their environments, and other humans much more seamless, really trying to understand kind of how our bodies, our physical environment, our virtual environment could be leveraged to access and manipulate data and digital information, but to take it to kind of a level higher, really how we can use our bodies, use our kind of physical environment, use movement to leverage our cognitive processes. So in this book, we have a survey of the technical foundation, the conceptual foundation, philosophical foundations, cognitive foundations, aesthetic foundations of tangible and embodied interaction. But we also look into the future of where we think this field should go and kind of trying to put together an agenda both for researchers and for practitioners in this area. And since we're all here in UCL, you should be able to access the book for free from the ACM Digital Library, the UCL membership. So I put there the link. And this is a nice illustration that Caroline Hamos created from the book, but it really highlights some of the unique aspects of tangible and embodied interaction, sensing and extending the body, accessing information through our perceptual motor skills, facilitating interaction and collaboration with people and with the environment, and mediating creativity, collaboration, expression, speculation, experimentation, and debate. So we really think, how can we use, right, extending and sensing the body in order to empower people to connect with each other? So when we wrote the book, we were really thinking about kind of the changing landscape, both in terms of technical development as well as social development. So we're thinking about topics such as kind of AI and robotics and data science, immersive technology that becomes more available, but also social issues that are critical at the time. We kind of wrote the end of the book during the kind of midst of the pandemic, thinking not only in kind of terms of pandemic as public health, but really thinking about well-being and mental health and kind of what does it mean when we work on interaction, thinking about the future of work and learning, thinking about risk for democracy, especially the intersection of AI and democracy and how we can design technology that empower kind of democratic processes rather than risk them. So the work that I'm going to talk about today is at the intersection of developing new technology and frameworks, prototyping interactive systems, and studying their impact through evaluation, with the focus on how do we enhance collaborative creative work. And you'll see that creative work we interpret kind of very broadly and with different kind of users. So the first project that I'd like to focus on is a project that thinks about exposure to nature and specifically exposure to virtual nature. So this project is something that we started to work on in the midst of COVID, when people were working from home and had a really limited access to the outdoors environment. There's a lot of documentation of how kind of natural environment is critical for well-being and for creativity. And we were all missing access to this resource. So the question that we came up with is, can we replicate some of the benefits that come from exposure to nature through virtual nature experiences? And if we provide some virtual nature experience treatment, what will be the impact on stress, on focus, and on creativity? So this was part of a large grant collaboration with Andrew Kuhn from University of New Hampshire and his students, and with John Lee from University of Wisconsin. And we have been working together, and the grant was actually awarded to us a year before COVID in 2019. It was awarded for us to study what we call the mobile office, study kind of work from outside the office. Specifically, we were thinking of work in future kind of automated cars. So if you don't have to drive, what does it mean for your ability to do work in the car? But work outside the office became very quickly something else. It meant work from home. And there are a lot of similarities between work from home and work from a future automated car. You're not in your office, you're not in a physical space with your colleagues. You have a lot of interruptions that you have to directly kind of attend to. It could be your kid if you're at home, or it could be a vehicle or going back into driving when you're in the car. So that was kind of the background for this investigation. But in order to answer this question, which is what is the impact of virtual exposure to nature on our focus, on our ability to focus, on stress, and on creativity, we had a 9 weeks study. So we identified 20 individuals, and these were individuals that were either in urban or suburban environments, so they didn't have regular access to nature. And we shared with them, we gave them a Quest device. And throughout 9 weeks, we structured the experiment so that we first, in the first 3 weeks, get a baseline measurement of their own self-reporting on focus and on stress. And we test creativity, and I'll talk in the next slide about how did we test for creativity. Then we had a survey with them, and then in week 4 to 6, we asked them for 10 minutes a day to use a kind of nature exposure in VR. And then in the next 3 weeks, we used the exposure to kind of virtual nature, plus we used some practice mindfulness application in addition to the virtual reality nature experience. And throughout that entire time during the work week, we had daily check-in with them, and I'll show how daily check-in looked like. I have to say, this is preliminary investigation. These were 9 weeks in the fall of 2020. There was a lot happening in the world and a lot happening in the US with the election. So there was a lot of noise in terms of stress and focus. So we have to take that as kind of preliminary investigation, but it was a 9 weeks investigation, which we thought will give us some insight. So I talked about evaluating creativity. We used 2 standard tests to look at 2 different aspects of creativity. And of course, this is a limited approach to how to measure creativity, but we use, right, the remote association test, in which every day they got kind of 3 words, 3 sets of 3 words, and we asked them to connect. So what is a word that can connect cottage, Swiss, and cake? Cheese, right? So that's kind of your ability to draw connections. And I don't know if it's the New York Times Connections app is popular, but New York Times came up with this game, Connections. It's really the RAT test. It's a lot of fun when you have free time. And then there was the alternate uses task, in which you're given an object, for example, a paperclip, and you have to write as many kind of possible uses for that particular object. And that's kind of measure your divergent thinking. So these are not studies that we invented. These are widely used in psychological evaluations. And this is how our daily text-based check-in look like. We ask them to self-report levels of focus, levels of stress, and then to answer, right, the RAT test and the AWT test. So here we have kind of on a scale of 7, that was their daily self-reporting, and then they provided the answers. And they received that text kind of every day during the work week, during work hours, and they could set up what time would be a good time for them. Okay, so you give kind of a sense of how it worked. Okay. So here are some results. What we see in terms of self-report levels of focus and stress is that the VR exposure to nature, which was just 10 minutes a day, made a difference, right? We see significant difference in reported, and I guess there was, again, a lot of noise during that time, but this is self-reported. Stress and focus, we see decrease in stress and increase in focus when we had the 10 minutes VR intervention. And we see that that kind of persists when we added the mindfulness intervention on top of the VR. In terms of creativity, the picture is a little bit more interesting. When we look at convergent thinking, right, which is the remote association test, we see that VR and mindfulness, when combined together, did make a significant impact on what we like to evaluate as convergent thinking. And you can see the difference both in terms of correctness as well as in terms of the response time. But with divergent thinking, we see a picture that is more complicated. We didn't see a significant impact on the number of the different numbers of users. Remember, this is how we measure the number of users. So that's one way to look at it. But what's interesting to look at is the creativity of the responses. So we use semantic distance as a measure to how creative, because you can provide 15 users of a shoe, like we saw in the test, but they're all very similar: to play sports, to play football, to run, right? Or you can provide ideas that are kind of remote in terms of the semantics, for example, to play football and to plant a plant inside the shoe. So this will be kind of more creative because there is semantic distance. And what we're seeing here is that the VR plus mindfulness improve the semantic distance. But this is something that we still need to explore with divergent thinking.
VR plus mindfulness. What is the mindfulness part? And was there a condition just mindfulness?
No, it was VR plus kind of mindfulness practice through an app. So it was exactly the same VR intervention, plus we added a mindfulness aspect. And we didn't study only mindfulness as a condition because there is so much documentation that only mindfulness work, right? Only mindfulness, there is so much documentation that it is effective in impacting focus and creativity. So we were interested in the impact of the VR, and we wanted to see that the VR doesn't take away from the benefits that we expected to see from the mindfulness. And we also had interviews, check-ins with the users, with the participants throughout the time. So we see that they found it kind of calm, relaxing, refreshing. It helped with their focus. And it also provided an escape. And as I said, this was a very difficult time due to the pandemic, but also the political landscape in the world. So just summary of finding is that VR, only 10 minutes a day, increase focus, reduce stress to some extent, right? And VR plus mindfulness, when combined, improved convergent thinking, but we're not sure about the impact on divergent thinking. What's important to us here, and I think this is the most important result, is that this is just 10 minutes a day, right? This is a preliminary study, but the intervention is also very lightweight. So there is space for us to really explore what it means to be part of a natural environment that is virtual, and what it means to work together or to be together with others, which is something that we didn't look at in a natural virtual environment. So that takes me to another study that we conducted during COVID. I worked with a very large group of coral reef scientists. So this was a group of coral reef scientists that were collaborating through a National Science Foundation grant. It was an interdisciplinary group. They had mathematicians, biologists, material scientists, engineers, data scientists working together, and they were distributed in 7 different institutions. So their collaboration, even before COVID, was an online, mostly online collaboration, but they were meeting a few times a year, especially to start kind of new research kind of questions or to write new grants together. So the questions that we were asking at these stages, how can we think about benefits from being together in the same virtual space and have some embodied presence in that virtual space? How will it change the creative aspect of the work of scientists? And just to give context, here are 2, right, Nobel Prize winning collaborators. We have Crick and Watson, and we have Jennifer Donda and Emmanuel Charpentier, who got the chemistry Nobel Prize Award in 2020 for the invention of the CRISPR genetic editing system. And both of them in their books describe how important collaboration was to making breakthrough in science. And specifically, Watson in his book described this tangible physical model as a way to enhance the cognitive process of trying different hypotheses, these shared artifacts. And here we see Jennifer Donda working with Emmanuel Charpentier with kind of a 3D printed molecule. Again, they've been working mostly remotely, but they really describe how effective was the time that they were meeting together in person. So we were trying to replicate this importance of shared artifacts into a virtual environment to see if it has a similar impact on being creative and providing scaffolding. So this was a qualitative study with 14 scientists, and we asked them during their 4 weeks of summer research to meet in a virtual environment instead of Zoom. So they conducted their weekly meeting within a space that was designed by the Spatial app using the Oculus Quest. Their postdocs were responsible of designing the kind of virtual space for their meetings. So we only gave them kind of the application with the room, and they arranged it. And we were interested to explore how they ran their meetings now that they had the freedom of being together in that space, and how they organize the shared artifacts in that space. So what we saw is that they had very different styles of meetings. They had guided tour, which was really, let me take you through my research. But here, let me take you through my research was, right, embodied. You really walk the corridor of the research, and you start with the motivation, and you get to look at the data. And it was really interesting to see how they organized the data. They replicated studies, and they used two walls, one in front of each other, to look at the results. So here you have kind of the original results, here you have the replicated study, and you can really compare them by looking at them wall across from the other wall. So guided tours. Exploratory tour was, let's take a few minutes to explore the data and then get together. So everyone got to look at whatever is interesting for them. Some meetings really revolved around one central artifact. We talked about the DNA model. Here is a model of an artifact, which is a molecule that they have been working with and they explored. And sometimes it was rehearsing kind of talks for PhD students or seminar presentations that they use a different space for. But they had full control of organizing the space, deciding what will go where. And this ran for 4 weeks of meetings. So these are some of the things that we found. There were many affordances that supported the cognitive processes. We saw that kind of from their interviews, we saw increased focus and engagement. We saw increased sense of presence. They felt as a community, they were really together in the same space. There was autonomy in exploring the data. They could go around in their own self-pace. There was not one person that was controlling, sharing the slides on Zoom and moving on. They used the spatial arrangement in a way that provide meaning and help with their thinking. And they had this physical manipulation of the object that they have been looking at. And these are some helpful quote. I'm just going to read one of them, which is, I really like attending VR presentation as opposed to Zoom ones. There is more sense of community and it's easier to focus. And here is really interesting to think about what it means that everything is on the walls and the use of the environment as scaffolding of the cognitive processes of going through the data and thinking about different hypotheses together. And here, again, this opportunity to look at multiple things side by side, leverage the virtual environment. There were lots of limitations. VR was difficult to use. There was limited whiteboard and note-taking functionality. Really, they couldn't take any notes. They could take shared Post-it notes as they walked around, but there was no opportunity to take private notes or to share thinking with others. There were no non-verbal cues. The avatar were kind of weird, and that caused some communication issues. And there was a lot of friction in organizing the space. I mentioned that the postdocs were the one that organized the physical space. Everyone tried, but it was really hard to put things on the wall. Your hand will kind of keep going through the wall. And it was just difficult to use these spaces in the way that they envisioned. We were specifically focusing from now on trying to help participants in these meetings to build on each other ideas through effective note-taking. So we all sit in conferences and we know how important it is to kind of take notes, and you have an idea that was just triggered by an idea that you heard in the room and you would like to kind of have a record of what is happening. This was very difficult to do in VR. So the PhD students that learned this investigation went on to develop a kind of robust and fluid note-taking application. So this is Embodied Notes, and this is kind of the note-taking application that Montserrat Olashbekan developed as part of her PhD work. What we're seeing here is the ability to take a note, which is a voice note, by recording and attaching it to a picture of the artifacts or the context within your present in the virtual environment. And this note is being stored in a sphere, which, if you're familiar with the kind of tangible marble answering machine, was a reference to this marble answering machine. But it was stored in a sphere, and the texture map around the sphere would be the image to provide you a context of what this is, a note that was taken next to this particular artifact. It could be stored in a virtual notebook, and then it could be shared with individuals or shared with the entire room. Whenever you record it or replay it, right, no one else would be able to hear you speak. So there was this private aspect. And here's a short video that shows how it works. I don't think we have sound, but I can take you through that. Okay, so here is kind of creating a note and kind of speaking into your hand. You're muted when you create the note, you take the context. And now that you have this note, you can store it in the notebook. You can delete it, you can share it with others, and it's all very physically kind of embodied interaction. And there was a storage space that was attached to your arm in which you could either have your personal notes or you could leave notes next to shared artifacts. So you go into a virtual poster session and you want to leave a question to someone else, you leave it kind of floating next to that poster and it could be revisited. So that was the embodied note. Great. So I want to move to kind of the recent work that we're looking at, which is for now slightly divorced from the tangible and embodied interaction, but we're really excited to kind of reconnect with human AI collaboration and group AI collaboration back into a rich kind of multi-sensory environment. So this is a recent Kai paper, and it looks at group AI collaboration within the context of creative ideation. So here we look at group ideation that typically start with some sort of a problem statement and go through a divergent stage in which we would like participants to contribute as many possible ideas. And ideally, this will be many possible high quality ideas that are divergent from each other. And then there is a convergent stage in which you expect users to select one or more ideas, like a subset of ideas that are more promising, and then develop them further. So we were really interested in how LLMs could be helpful to promote group AI collaboration. And specifically, we wanted to see, does it kind of promote the divergence aspect? Do we get more ideas? Are they different ideas that we get when we involve AI in the process? And can they be helpful in selecting ideas as we move into the convergence stage? So we developed this kind of group AI ideation framework. We worked with a specific type of ideation process that is called brainwriting. And brainwriting is like brainstorming, but instead of being just a verbal process in which you throw ideas into the room, you start with a process in which everyone in parallel writing down their ideas. And because everyone is working in parallel, it's considered more equitable. So everyone can contribute, everyone is heard. And the way that we treated the LLM, the AI in this case, is we treated it as just one more member. So the sense is that every member is contributing their idea, the AI is contributing their ideas, then everyone is reviewing all the ideas together, developing additional ideas before moving into the convergent stage. And we thought that AI could come as an additional team member in idea generation, and then can be involved in narrowing the design space, and then in enhancing the ideas that were selected for further development. So the first activity was done in February 2023. So it's like soon after the release of GPT. And this is still GPT-3. So what we did is in our tangible interaction design course, which is an advanced second human-computer interaction design course, when the students were brainstorming for their idea, we changed the brainstorming to brainwriting, and we changed the brainwriting to brainwriting with AI. So the idea was that they will use this environment. Each participant will contribute their ideas. Then they will prompt GPT to contribute additional ideas. After that, they will review all the ideas, develop additional ideas. The additional ideas could be additional human ideas or additional LLM ideas. And then at this stage, when their board is filled with ideas, they will be able to select the most promising ideas and develop them further. So there were many questions that we asked about the impact of bringing an LLM as an additional member into this ideation phase. But one of them was how the ideas that are generated by LLM are different from the ideas generated by humans. And this is one answer. So the LPA is a semantic analysis clustering algorithm. And what you see here is the frequency of terms that have been used in the entire kind of data set of ideas. So these are the words that are most common in human-generated ideas, LLM-generated ideas, and collaborative human and LLMs together generating ideas. And what we're seeing here is the signature of the GPT-3 ideas compared to the frequency of all of the ideas. So we see that device, surface, light, user, posture, these are kind of more specific terms. We used much more in GPT-3 ideas compared to human ideas. And the word people, wearable, right, screen, or time, space, these are all the words that were used less in GPT ideas compared to human-generated ideas. So what it really means is that humans' ideas were much more abstract when we looked at them. And the GPT-3 ideas were much more kind of technical and specific. They had more details. The ideas that were actually selected by each group, right? This was a course, so we knew what idea they're actually going to select and work on for the rest of the semester. All of the ideas that were actually selected by groups to work on throughout the semester were ideas with collaborative origin. So these were ideas that were kind of came in the second stage in which humans and LLM worked together to select an idea. About 50% of the students thought that GPT-3 was helpful, but 30% of them thought that it was not very creative, that it was very hard to prompt, that they couldn't get it to kind of come up with original idea. I want to remind you this was my GPT-3, not GPT-4. Plus, this was really early on, kind of many of our students just learned to prompt early in that stage. I think that the prompting is less of an issue at this stage because I expect students to do less prompting and to use more kind of back-end prompting tools rather than having to engineer the prompt by themselves. And then at the end of the semester, we looked again, and again, 50% of the students thought that GPT-3 was helpful for them. So at the end of the semester, we had all these ideas that students generated. The students went home, so the students are no longer involved, and we had access to GPT-4 at this stage because it was released. So this is the second study that we conducted. We look at all the data sets that the student generated, and we wanted to see whether we can create a GPT-4 evaluation engine that will provide feedback. Remember, this is just theoretical because the students was no longer there. But specifically, we wanted to see if we can provide feedback that will highlight kind of the worst ideas and help to filter them, and will not rule out the good ideas. And we deemed good ideas by the ideas that were selected by the student themselves. So we wanted to see that if we run a GPT-4 evaluation, it will not get rid of the ideas that the student thought great. But we also compare it to evaluation by humans. And we had human experts, which are faculty who are teaching similar courses. And we have novice students who are students that participated in previous semesters of the same course and were asked to evaluate these ideas. And we see that in general, right, GPT-4 had a reasonable agreement with the experts and with the novices. Most promising is that bad ideas were consistently bad, right? So it's helped to filter ideas, and that good ideas, all of the ideas that were selected by the students, none of them was filtered out by GPT-4. So there were some other questions that we asked. The first question was a question of consistency. So we ran it kind of 30 times, 29 of these times actually worked, to see if we get consistent results. So first we wanted to see the internal consistency, and the internal consistency was relatively good. Then we wanted to see the consistency with human evaluators, which is what I just showed you, which was, again, kind of relatively good. And we wanted to see that the high rating to all of the ideas kind of, and high rating is that the 4 or 5, there was no agreement between the 4 or 5, but we wanted to see that all of the good ideas selected by the students were rated as high ratings, and they were. What we did this semester, that is not yet in the paper, is we used it in the classroom as a way to provide immediate project-based feedback to students. And I don't know if you can see it here, but there are 3 criteria that the GPT-4 commenting on. We looked at how relevant the idea is to the problem statement, how innovative is the idea compared to existing solution, and how insightful the idea is in kind of nuanced understanding of the idea. So this criteria didn't come out of nowhere. This criteria came from a lot of literature about how to evaluate new product ideas. So we kind of taught GPT to evaluate idea based on these scales, develop the scales, and then again, tested them for internal consistency. And then this semester, we tested them with the students to see that beyond the numbers, the advice that is provided and the feedback itself is helpful for them. And here the idea was to scale the instructor, right? I'm only one in the room. I cannot provide immediate kind of insightful project ideas to all students. But what if I have, right, a GPT-4 evaluation engine that can provide them with this immediate feedback on the go, helping them to filter bad idea. And then we wanted to look at what does it mean to develop further the good ideas. So this is a tool that we're currently developing, and this is a prototype. And here we're using a method called the 6 hats or 6 thinking hats. This is not a method that we developed. It's a method that is very well known in management as a problem solving. And the idea is that different team members wear different hats that provide different perspective into the ideas. So here we ask GPT to wear these different hats. So the yellow hat is the optimistic hat, the green hat is the creative hat, the black hat is the pessimistic agent, We have an emotional agent that simulates the emotional response of the audience for this particular application idea. We have an analytical agent that come up with some technical evaluation and solution. And then we have the blue hat, which provide a summary. So we ran this application as a way to provide additional perspective on product and idea development that are not necessarily in the room, with expertise that student maybe not consider at that point. And in the current version of the application that we're using this semester with my students, we also have an opportunity to have a conversation with the hat. So you can ask questions, kind of the different personas, and get feedback from that. And then you have a generated summary by the blue hat. So just as a summary of our work with group AI, we see that LLMs could be useful and helpful both in convergent thinking and divergent thinking. So they help you kind of generate different ideas as well as converge ideas, but they have many limitations that we need to overcome, especially in terms of divergence and getting creative. We try to resolve the prompt engineering issues by providing now tools that are using back-end prompting. And we're really focusing on evaluating these tools in the wild, kind of deploying them in the classroom with students and see kind of how they help both in terms of the product development as well as in providing helpful feedback to the students. So just going back to the big picture, right, and the changing landscape in which we all worked in, we really look for deep engagement in society with societal challenges, focusing on the future of work. I have a new project that I hope to talk about next year that has to do with democracy. I'm working with a political scientist on looking at kind of group AI application for resolving and de-escalating conflicts on campuses. And we look at really how we can take these environments and make them multisensory. So how can we combine kind of multiple people working together in the same physical or virtual space with AI assistant in a multisensory way that really leverage their cognitive processes. So this is where we are. I'll be happy to answer questions. I want to conclude with a plug for the KaiWork conference. So if you're interested in the projects that I kind of presented and many similar topics, I'm involved in organizing this conference. This is a conference with very strong UCL connection, with Anna and Duncan being involved in the organizing and the steering committee. And if you can travel to Newcastle to join us next week, that will be great. And if you can't, consider joining us online. This is a conference that is so far, and I hope it will remain that trajectory, is known for a very effective hybrid experience. So you'll get to network and meet people even if you join us online. Thank you.
Amazing. Time for questions.
Thank you, Orit. Really interesting work. I have lots of questions, but I will start with one. I was curious about in the project with the 6 hats. As someone who recently started playing a bit with ChatGPT, could you share a bit your experience in? So I assume that like each hat basically has like a system, or I think you call it backend.
Yeah, so it's a system prompt, and at this point, it's like back end is because it doesn't engineer by the student; it happened by the system itself.
By the system, or like, is it sort of like by the people designing it? Like I assume.
No, so it's by the people designing it, but the user is not interacting with it, right? The application runs it when the user say check in with the hat.
Yeah, and so I was curious if you could share the process of like developing the 6 prompts. How did you go about it? Did you do a lot of tests with like fictional things? How many iterations? Because one thing that I'm finding interesting, again, as a novice kind of like GPT user, is understanding like when do you stop trying things? Because in principle, you could have infinite combinations of prompt options.
Yeah, so we went through an iterative design. So the first approach was human-based approach. So in one semester, we asked the students to assume the 6 hats roles. And we wanted to see how they kind of think about it. So the first was, let's assume the 6 hats personas and not use AI. So each of the students were able to provide some insights, but these are undergraduate students on a new topic. The insights were relatively limited. And then we thought kind of each of the hats basic prompt engineering, and we told them, okay, now you can use AI, you can use ChatGPT to help you be the persona. So the student is still the persona, one of the hats, but they can use GPT to kind of get some feedback. And we wanted to see what they consider creative and helpful and what not. Then we went to designing the prompt ourselves. So we used a system approach, right? We defined a persona for each of the hats. And then we provided the expectations. We provided a few examples. And then we tested it on the idea data set that we had from before. And we went through that kind of feedback manually to see that A, it all makes sense and that we think it's helpful. And then we used it in the classroom. And we collected students' responses for these different hats. And now we're actually developing the system again to be useful and test it complete in the fall. So it still requires, right, kind of human-centered iterative development, but this time involving AI.
Thank you.
Thanks very much. That was fascinating. I wanted to ask you about the language and ChatGPT in relation to the body, the human body. And I was wondering if you could say a little bit more about the vocabulary that some of it which you showed on the slide. I think you said something about ChatGPT in general in comparison to human ideation tends to talk more about the technical, if I understood you correctly. There were some words then that did refer to the body, like posture. So I was wondering if you could elaborate on that a little bit, on how ChatGPT talks about the body.
Sure. So first I want to say this is not yet ChatGPT. When we ran the study, it was GPT-3, right? So it was before the release of ChatGPT. It's just important to be accurate because the models changed since then. So that's kind of one detail. Second is this was a tangible user interface course, and the prompt was about tangible interaction and emphasize embodied, right? That was the problem set for the student. So that's one reason why some of the ideas that came back from the AI involved bodies such as posture. It's interesting because kind of people, right? The students in the course didn't use the word posture almost altogether. They used wearables and they used moving around and they used gestures, but posture came as a more technical term that was introduced by the AI. In general, it was interesting. I've been teaching tangible interaction for many years to undergrads, so I can kind of notice the trends. The preliminary ideas that come from students are very screen touch-based driven. So it's hard for students when they first start thinking about tangible and embodied interaction to break the paradigm of what we know about desktop or touch-based interaction to move into embodied interaction. So a lot of time my feedback is pushing them and say like, how about we think about materials? How about we think about a body? How about we think about movement? And we were hoping that the feedback provided by the AI will kind of push to that direction as well. That didn't happen with GPT-3, but we did see more, not body kind of references, but more material references. So things such as description of different materials, as well as a wider variety of materials was introduced by GPT-3. So this is a really interesting question, and we will keep working, with the tangible interaction design and the new tools that we design, which now are powered by newer LLM models. And hopefully the way that we'll be able to use them will also be multimodal rather than just text. So I would like students to be able to, sketch their idea and now get a description, which is more kind of rich in terms of the different personas. So I think that we're going to see a change in how we have these GPT models refer to body and movement and embodiment compared to the very early experiment that we ran.
Thank you very much. I have questions about the first two papers that you mentioned. So with the mindfulness and VR sort of in nature, you highlighted that it was controlled to only be 10 minutes per day for participants. Was there any oversight over that, or could people use the Quest as much as they wanted, but they were required to use it for 10 minutes?
They could use it as much as they wanted, but they were required for at least 10 minutes a day, use a specific app that provided nature experiences. And there were actually 3 options for which nature experience to choose. We chose one that we thought are equivalent, So none of them was, more impressive or striking than the other, but they could alternate between the three of them. The compensation that they got for the study was the VR set itself, and they mentioned that some of them continued to use it, some of them never used it again after the study. There was a lot of noise, as I said, like some of them did use it for more. It was very hard to control. It was really in their homes remotely, but everyone was for at least 10 minutes a day using it.
Thank you. Yeah, so obviously the question that comes from that is sort of how much is too much of a good thing, right? So was there any maybe difference between people who were using it for hours a day, right? Were some of them maybe using it in their work, or as we see with newer devices where people can have environments that they actually do their work in. And the other question I had was about the second papers, specifically with taking notes, sort of the voice notes about objects in VR. And I was wondering if those objects can actually contain conversations. So you can record your voice, and I don't know if there's any speech-to-text technology there, so you can read it back instead of listening back. But can people leave their questions on that note and continue like a comment thread, essentially? Can you have a sort of object that represents a conversation that happened in that space?
That's a great idea. Like many other fun projects, the student graduated, so it stopped there. We did envision text to speech, so it really translates into notes. And I really like your idea of a conversation. What we had is, we didn't have the conversation thread, which I love, but we had the idea of leaving it next to a kind of shared artifact. So leave it next to a poster or leave it next to kind of a molecule model, and people can come and leave their own note as a response that they can share with you. But I really like thinking, how do we create a conversation object and combining it into a different shape or a different bigger sphere? Yeah.
I feel that's it. Are we good for questions?
I was wondering about the VR environment and the collaboration aspect. My question is about the team that met there. I understood that they already know each other. So I was wondering if you had any thoughts around how this environment could work when the team doesn't yet know each other.
Yeah, I have many thoughts, but we didn't run an experiment. But I think there is a great potential of team building, right? This is a team, they work together, but many times, especially when people work more from home today, you have to build a team from people that are work remotely. And I think that the literature shows us that embodied experience, going through an embodied experience together, help to build cohesiveness into a team. So I'm really thinking about what kind of experiences we can design in this virtual environment that will be dedicated to building a team before even getting into the ideation and sharing information phase. And I think it has a very rich potential compared to Zoom meetings and very thin, right, Zoom introductions. I think that nature, right, could be part of this. Can you take together a walk in nature, explore kind of natural objects? Can you go through some light physical activity that will kind of add to the embodied effort of the team? So many ideas, but no concrete studies quite yet. I have to say that as I'm here, my students in the lab are now running a study in which we have a specific structured ideation activity with kind of collaborative teams that don't know each other in VR. So we don't kind of still look into the team building, but we have 3 individuals working together on creative ideation in VR combined with AI. So bringing many of the elements together, and we compare that ideation into ideation with virtual whiteboards, which is currently kind of the state of the art in team ideation. We just started running the study, so I don't have a conclusion or finding to share, but hopefully I will in the future.
Okay, thank you very much.
Great.
All right, it's fantastic.
Thank you.
Very good. So yeah, just to conclude, thank you so much. Really enjoyed the talk. So
Thank you.
we're going to take a little break and probably just move up to the second floor just for informal chats if you want to join there. And then probably about half an hour or so, we'll start on this tour of UCLIC's former homes.
Great.
And Anne's, I think you probably got them all there, right? I mean, that's the question, going back through the different homes we've had. And then on, yeah. But technically, I'm not sure, is that really UCLIC though? Because UCLIC was founded when it was only.
Economic unit. But when it became really UCLIC, it's
I think if we have a good number though, we could actually get photographs of people. We could all have like a gathering and like, yeah, I could see this being a nice article, right? As a tour on a beautiful day outside, seeing all of our former homes and current homes. And then afterwards, go to, it's a beautiful day, so to the rooftop bar of the George Birkbeck, I think, so 4th floor Birkbeck. And then we'll head off to dinner. So thank you.
That's great.
And then, sorry, we're taking a break next week because of Thai work. So many of us will be there. And then we've got the very, very last seminar for the season the week after on the early July one. And then we're taking a break. So, sorry? The 3rd of July, yes. And then we take a long break. So thank you very much.